This is an antique radio power supply kit that I built that Antique Electronic Supply sells, or Tubes and More on the internet. It's actually a pretty nice little power supply. It's pretty easy to build, and it's fairly breadboarded, as you can see. I built this power supply to test my Atwater Kent Model 20C, but I also intend to use this permanently in my Radiola 20 if it works out okay for that radio, and I think it will. But I'm going to probably build another power supply, maybe not this one, but one that I have from a schematic that uses 2 transformers instead of 1. But this is the power supply that I'm going to test the Atwater Kent 20C that I restored. Well, when I put the Atwater Kent 20C back together, I had assumed that I had tested everything, all the components, before I put it back together. But apparently, I missed something, and I've already found something that I missed. This wire wound resistor is open. This is supposed to be a 600 ohm resistor, but it's open. And this resistor goes right where the antenna comes in on the first tuned circuit is in the circuit between the antenna transformer and the first amplifier, tuned amplifier, and it's open. Now, I found one that was open when I restored the radio. It is this one right down here. It's right here. I have a resistor soldered underneath. It's a 600 ohm resistor, and if we look at the schematic, if I can focus in on it, I will point out to you that this resistor right here is open. So I'm going to fix that, but I'm going to work my way from one end of the schematic to the other one, checking the radio out to make sure that I didn't miss anything, and then I'm going to retest it. So I have basically repaired that resistor. You can see I have resistors soldered underneath. I took the wire off, the resistance wire. I've got my meter connected up to the plate where it is supposed to attach to, and here's the pin that goes to the grid of the tube. And if we look over at my meter, let me get a better connection here. 600 ohms. So that part of it's fixed. I might not have missed it. It might have, those wires, the way they make these resistance wire resistors on this phenolic tab, the way they connect the rivets up and everything, they're really prone to failing. And it might have tested good when I put it together, and it might have failed at one point or another. It's very difficult to say. It could have failed when I soldered the wires back on, because I had to take almost all this apart to clean and repaint this chassis, because this was a mouse hotel when I bought it at the flea market. This center coil right here, this had to be replaced. A very nice collector sold me this one. The mice had completely annihilated the coil. So I'm going to continue to go through this to see if I find any other faults before I hook it up and test it again. So here's the next thing I had to do, which I don't think I would have missed this, but you'll see right here this big old antique capacitor. That's supposed to be a 0.3 microfarad capacitor, and it's right, let me get my pointer, it's right there on the schematic. It goes between the 67.5 volts and ground. That's where that capacitor is. I have my meter. I put these capacitors in right here, and I have my meter attached to the 67.5 volt connection, and this is ground, and so we will see what we get. 2.5 mics. That's close enough. That's as close as I can come with these two ceramic capacitors. So we're making progress. Now this I did when I first restored the radio and I had it all apart. You'll notice here this nifty glass tube. That's the grid leak resistor. And on the schematic, and hopefully you can see it, it is this resistor right here, 2 to 4 megs. What I did, the resistor naturally is open. They all do. They all open up, these old grid leak resistors. What I did was I soldered a 2 meg resistor underneath. You can't see it, but it's soldered underneath.